All right, welcome back to the next set of videos. Starting in chapter 6, which is chapter 6 is applications of trigonometry, trigonometric functions. Okay, so we're gonna start with right angle trigonometry, which, to be perfectly honest, this is stuff that I think we all should know by now in this course, but it's sort of nice to put it all together. Okay, so we're going to go ahead. Let's start with just the basic format. We know sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta, this is opposite over adjacent. Now keep in mind, this is for right triangles, okay? These things only work really for right triangles this way. So we're gonna actually move out of right triangles, but not yet. Okay, so for today, we're actually gonna have right triangles, which is sort of like the easy case. Okay, so let's start. We're just gonna start doing problems. Number 12, they give us a triangle. So our triangle is like so, somewhat. Let's pretend. Okay, it's actually, I did bad rendering of that triangle. Let's try it again. That's better. Okay, so we have a right angle here. Okay, they tell us this side is 15, this side is 17, and this angle's theta. Okay, so we've got to find the six trigonometric functions, six trigonometric functions for theta. Okay, so the first thing that we should do, we should probably find this value here, which we'll call, let's say, I don't know, y. Okay. Sorry about that, it's giving me a little lag. Okay, so y equals the square root of 17 squared minus 15 squared. Okay, which equals, let me do that in my calculator, 8. Okay, I did not know that was a triangle. I should have known that. Huh. I did not know 8, 15, 17 was a right triangle. I should have known that. I can't believe I've gotten this far in my life without knowing that. Okay. So we got to find the six trigonometric sides. Or the six trigonometric functions. Sine of theta is, of course, this opposite over that hypotenuse. 8 over 17. Cosine theta is adjacent over hypotenuse. 15 over 17. Okay. The reciprocal of sine is cosecant of theta. So cosecant of theta is 17 over 8. Okay. And secant of theta, the reciprocal of cosine, is 17 over 15. Tangent of theta, 8 over 15. Cotangent theta, 15 over 8. Okay, that's it. That's it for number 12. Let's take a look at another. Oh, you guys can pause it if you need to slow down. 16. So in this one, they give us okay, we have a right triangle. And we have sine of theta equals 3/4. Okay, so all we're going to do here is we're going to draw a triangle. Oh, bad one. There we go. There's a nice right triangle. Make it a little bigger. Okay. Sine of theta is 3 over 4. And we just put theta right there, the way that we were doing it. Okay? Sorry for the delay. All right, let's call this thing x. And we got to find x. So remember, x squared plus 3 squared equals 16. Okay, so that means x squared should equal 7. X is the square root of 7. Okay, so now we can find all our trigonometric things. Okay. Sorry about that. So, where was I? Cosine theta is root 7 over 4. That's this adjacent over the hypotenuse. Okay. Tangent of theta. Tangent of theta is 3 over root 7. But we're going to rationalize that. Okay, remember we want to get rid of the square roots in the denominator. Okay, so tangent of theta we're actually going to write as, sorry, a piece of paper keeps flying onto my screen, is 3 root 7 divided by 7. Okay. Now, we also have the other 6, or the other 3. Let's move this here. And we can do those quite easily. So cosecant theta, remember, is the reciprocal of sine. So that's 4/3. Secant theta is the reciprocal of cosine. That's 4 over root 7. Rationalizing it the same way we rationalize tangent. Okay, we're going to rationalize it the same way we rationalize tangent. 4 root 7 over 7. And then cotangent of theta, that's just root 7 divided by 3. When I went to there, I just went to this expression, and then I flipped it. Okay? So there you have all of them. The sine theta was given. Cosecant theta flipped it. Cosine theta, you needed to resolve the triangle. Secant theta, you needed to rationalize after flipping. Tangent theta needed to be rationalized. And cotangent theta just followed. Okay? All right, I'll see you in the next video.